Hi, this is Database by Doug. Today we'll cover working with dates. We'll be using the Northwinds database. And why do we want to know about dates and times? Well, in transactional systems where we record events, one of the things we're constantly recording is the date that something happened or when something should happen. Unfortunately, dates and times are fairly complicated in real life. There's different calendaring systems, there's leap years, there's time zones, etc. And so my advice is not to try and use your own date time calculations, but to just get to know the date and time functions and the way to work with dates on each platform you're using. So this video will be using the DateTimeTo data type. It's a newer data type for dates and times. It is recommended for future development. However, the concepts that we'll be covering will apply to date time and small date time, just at different precision. So let's do something simple. Let's get the current system date and time. Notice that this gives me a string representation of the different pieces. There's the year, month, day, hour, minute, second, and millisecond. To get any particular piece, I need a function called datePart. And what that will do is pull out the different pieces of the dates and times. So here I've separated each piece available to me and put them into a separate value that I could address or use independently of the entire date time. In addition to datePart, there are a couple of convenience functions for year, month, and day. Just for code clarity, unfortunately there's not one for hour, minute, or second. I do like these. Your code is clearer and thus less error prone, so I do like to use these when I can. Note that the results are all whole numbers. They're exact integer values, and they represent a part of the date time. So they don't represent some duration. This doesn't mean the whole month of February. It means that whatever this date time is has the value 5 for its month. So let's see how I might work with this in the orders table. Here what I'm doing is I'm getting the order date for orders that are in 1997 and are in February. And here I've ordered these so that you can see there's the end of the month. There are 29 different orders beginning on the 3rd and going to the 28th of that year. So note that there's some performance implications for how I phrase this. Well, that's for another video. We'll cover that in another video. So how would you instantiate or create a datetime literal? Well, there's a function called DateTimeTo from parts that will explicitly create a DateTimeTo from the individual components. And this is the preferred method, although you'll see many different examples of implicitly instantiating or creating a DateTimeTo. So just so that you see this, I'm declaring a DateTimeTo object or variable, and I am now assigning this value, which is a variable character or a string. I'm assigning it to a DateTimeTo. So there's an implicit conversion going on there. And if I run all this code together, you can see that it does what I intend for it to do. However, I have trusted SQL Server to make the right guess as to how I want it to be converted. In general, you don't want to implicitly convert things. However, SQL Server does provide a variety of formats, and especially if you're moving date times from another system where it is coming in as a string representation, you might have to do it this way. In general, if you're doing your own literals, it's best to be explicit and use the DateTimeTo from parts function. Now, another thing that I might want to do is move back or forward in time from a reference time. So that's done using the dateAdd function, and here I'm doing a variety of things, moving forward or backward from the current system time. And notice that the way the function works is there's the month, I can specify the unit, specify the number of units, and then specify the reference date time. So I can move forward by specifying a positive integer. I can move backward by specifying a negative integer. This is expected to be an integer, so notice that I did not say second 3.5, and here's why. So I'll show you that. And here is the current system time. Here is 3 seconds from now, even though I specified to move forward 3.5 seconds from now. And you can see there's 21 and there's 24. Why? Well, the function is expecting an integer, and I've provided a floating point, so there is an implicit conversion, and thus the 0.5 is effectively ignored. So just be careful, use the integers there. So what if we want to know the difference between two dates? There's a function called DateDiff, and here what I'm doing is I'm looking at the order date and the ship date and measuring the number of days between those two dates. Now, the way that this is calculated may seem a little bit odd. What it's going to do is count the number of day boundaries between the two dates. In other words, when it's counting the days, it's counting the number of midnights that elapse between this order date and the ship date. When we're doing weeks, it's counting the number of Sunday to Monday transitions or boundaries that occur between those two dates. So notice here that it says 12 days until shipped and 2 weeks until shipped. So it's saying 2 weeks even though 14 days has not elapsed. So just to show that more explicitly for this particular order, what I have here is there's the weekday of the order date and then the weekday of the ship date. And as you can see, 5 days have elapsed. However, 1 week has elapsed because it's gone from the previous week past day 7 of the week and into day 1 of the week. So a way to look at that is that in effect what's happening is it's day 6 of the previous week, 7, then there's a boundary, and then 1, 2, 3, 4. Therefore, it's counting the boundary. So, in summary, DateDiff returns a count of time unit boundaries that have passed. It doesn't really measure the time, at least not accurately. So in summary, DateTimeTo, datetime, small date time, they're all complex data types that you would operate on in the same manner. My advice is to use the functions provided. Don't try to roll your own or get under the covers and affect a DateTime's native representation. GetDate gives the current system time, DateAdd moves forward or back from a given point in time, and DateDiff gives the number of time unit boundaries passed between two dates. This is Database by Doug, working with dates.